Good morning, student.
Good morning, sir.
Say good morning.
Good morning, sir.
Very good. Now today, in our applied component drums and dies, today we will have the one experiment, and that is called as the determination of optical activity. Okay, of an organic compound. So this is the aim of the experiment. Now how we can measure the optical activity? First we'll understand about the optical activity. Why the substances are called as optical activity. So in this experiment, you know, there is an ordinary light. This is the ordinary light, and this ordinary light is propagated in all directions. Okay, and that's why we call that this is ordinary light. This ordinary light, if you pass through a Nicol prism, this is prism, it converts it into a PPL, plane polarized light. Okay, so now you can understand what is the difference between the PPL and the ordinary light, because it's in all direction and it propagates in a one direction. So this light we are supposed to allow to pass into the organic solution, and when this light come in contact with this, there are two possibilities. It rotate the plane polarized light in right side, we can say it is a clockwise, and in left side we can call this as anti-clockwise. So this light rotate the plane polarized light, and these substances are called as optically active substance, and those substances which do not rotate the plane polarized light, they are called as optically inactive substance. There is another possibility in this, you will get this, but there is no change in the plane polarized light. Okay, so in optically active substance, those who rotate the PPL in right, so they are called as the dextra rotatory compound. It is designated as D, sign is positive. And those substances which rotate the PPL in left hand side, they are designated by using a small l, and the sign is used negative. And this substance is called as optically inactive. This is not rotating the plane polarized light. So this is the property of not all organic compound but the few organic compound. Now why some compounds they shows only the optical activity, why they rotate the PPL, this is the question. Or which are the compounds they rotate the plane polarized light, that we understand. So you remember there is one concept, and that already we learned is chirality. Chiral. Okay. Chiral means it is also called as asymmetric carbon. Yeah. Asymmetric carbon. Now which carbon is called as asymmetric? A carbon having the 4 different atoms or group of atoms attached to it. That is called as chiral carbon. I will take this chiral carbon, suppose. Okay, now here is CH3 and here is OH. This is an example. Now this carbon is called as a chiral carbon because there are 4 different atom or group of atom which is attached to it. This is 1, this is 2, this is 3, this is 4. So this compound Can we say it is optically active? Yes. So those compounds, they have the chiral center, they are optically active. Now there are two types of compound. One is dextro, this is we call as dextro, and this is we call as leo. Dextro-rotatory compound, leo-rotatory compound. Have you heard about the glucon D? Yes. हम बोलते हैं कि glucon D चाहिए. Have you heard about the L-ascorbic acid, vitamin C? वहाँ पे हम लोग को L चाहिए. ग्लूकोज के लिए हमको glucon D चाहिए. It means some optically active compound, they have the medicinal properties. उनको medicinal properties होते हैं. And that's why we use in the medicine. हम लोग उसको medicine में use करते हैं. तो आज हम लोग को हमारे पास एक instrument है, so we can check the compound is optically active or not. And the second point is, if it is optically active, whether it is a dextro-rotatory compound or it is a leo-rotatory compound. This is one thing. The second thing, can we measure the angle? Now you can see it here by using the polarimeter, how much angle this rotate the plane. On that angle, rotation angle in this experiment, they are called as specific rotation. इसको नाम दिया उन्होंने specific rotation. And this specific rotation is designated as alpha. Okay, or we can say it is the angle of rotation. How much angle they rotate. Every compound, they don't have that same angle of rotation. They have a different because the structures are different. Their stereochemistry is different. So therefore, we have to calculate this alpha. We can measure this how much angle it rotates. And for that, we have the instrument. It is called as polarimeter. हमारे पास एक polarimeter instrument है. Now in this polarimeter, use the visible light. ये visible light use करते हैं इसके अंदर हम लोग. What is the wavelength of visible light?
400 to
4, very good. 400 nanometer to 800 nanometer. It's a visible light, and that visible light we will use it here. Okay, so that is the visible light here. We pass through nickel prism, and that light converts into the PPL, and PPL light we will apply. So this is the visible light. Okay, and by using this we can measure the alpha. Okay, alpha is angle, so we can see also it is called as the theta. Theta. So this theta value we can measure, and then we can calculate the alpha. Okay, angle of rotation आपको मिल जाएगा, and that we can convert into the specific rotation, alpha. Okay, so some compound they shows the value plus 54. Some compound they shows the value minus 34. Okay, so these values we have calculated by using alpha. These are the alpha values. And with the help of this value, we can also conclude this is dextro-rotatory compound, this is. Now today, I will give the sucrose to you, and another is the fructose and glucose. So there are 3 different compounds you can take it. You know already glucose, suppose this is a structure of glucose. 1, 2, 3, 4, 5 and 6. If it is D-glucose, I can write it here, and other groups are as it is. Here must be the change. And so this is the D-glucose. We will give today the D-glucose to you. And this D-glucose, you can use it and measure the angle of rotation and then calculate the specific rotations. Okay. So here it is optically active compound because it contains the 4 chiral carbon atoms are present. इसमें 4 chiral carbon. Like fructose is also optically active compound. Then today we will give the sugar. Now what is the meaning of the sugar? Sugar is composed of glucose plus. तो आज हम लोग डाइसैकेराइड आपको दे देंगे, and then from that you can see whether this glucose and fructose, what are their optical rotations, whether they have the same optical rotation or they have a different optical rotation. Is there any doubt in this one? This is the theoretical part I just explained. Thank you.